Morning, fellow tinkerers. Hey, it's Frankenmint. So I am here to just, I guess, do a quick video of a summary of my thoughts of the Ender 5 Pro. I've been able to use it for a couple of days now, and I finished my second airsoft lower, so that's exciting. I have no idea what you can kind of see or tell from here, just because. Oh, here I've got a remote, but I have a viewfinder, and the viewfinder's kind of far away. So here, let's zoom in for you. So yeah, this is it. It's completed. Um, it's probably hard to see because of the view, but there you go. Yeah. Like I found with the second run that I did with this, the support material like took forever to grow out. I think I probably could have gotten this done in 1/6 of the amount of time. I used 100% infill, I believe, or it might have been 80%. I didn't use any. I used a supporting material, but I didn't use tree. I also did still use a brim. This has been cold for, I don't know, 5 or 6 hours. Excuse me. Right. So some of my thoughts about the unit. The unit itself is well put together when it arrives to you. It's nice and compact, and compared to a Prusa Mindel 2 kit, it is much more convenient. In 2013, if you look at my video history, that's like the very first video I've got, is me assembling a Prusa Mindel 2. I found dealing with the glass panel and the thermistor sensors that went into that panel, and getting it all set up into the ramps board and dealing with the separate axes was a problem in 2013. 10 years is amazing what they can do with technology, because this was very, very painless, very simple and pain-free, as you can see in my other video. The bottom chassis, the 4 legs, and then the top chassis, and then the actual leveling bed itself that went into this little axis. The Z axis was actually already fully assembled as well, which, like I said, thank you, Creality. That was very, very convenient. I appreciate that. Right, so talking about some of the no problem. Talking about some of the issues I found with this, that if you've never done this before, these are going to concern you. Because I assembled that 3D printer in 2013, it was not a big deal for me. But like I said, the things you're going to need to be aware of are, one, I assembled everything, and the first thing I went to was to go to Auto Home, which is to set the bed leveling and to determine the Z, or the X and the Y axes. What was that? Oh, there's a little bit of a filament dust. Interesting. Yeah. So that it can actually set those constraints. There's actually little switches on these axes up here and back here, so that the nozzle head knows the limits of where it can go. So what I found was the Z axis was binding up at the very top, and it was getting stuck here, and it was making a noise. I've got that recorded for you if you want to look for it. The way I had to fix that was I actually had to manually turn this gear down. You see how I'm doing this? There's actually a gear down here, a piece of all metal gear. I'm rotating it counterclockwise and is slowly lowering the print bed. I had to manually do that to kind of have it go down the track a bit. I believe the reason for this, from my research, is that the default firmware is set to a lower step or tooth count. I believe it's only set to 400 steps rather than 800. It might be the reverse. It might have been that it's set to 800 steps, but this is only 400. Looking at this looks like this is 400 turns you going down. So I'd imagine that's what had happened. It was trying to go up 800, but it can only go up 400. So like I said, what I had to do was I turned this counterclockwise to lower the print bed, right? And then lowering the print bed like this, when I then ran to Auto Home, it actually finally went up to the top and actually stopped right at the top like I needed. So that's how I fixed that. The other problem I ran into was that you see this little brick right here? This is actually called the extruder. I'm used to old technology to where there was only one extruder, and the extruder was the nozzle head, which was up here. But no, this thing right here is actually the extruder. And so what that means is it is extruding filament from the spool as a line into the nozzle. And so the problem I found was that my extruder was feeding in reverse. And so it's supposed to go this way, and the teeth are supposed to turn like this, right? It's like I'm adjusting little knobs. Yeah, see, and the teeth are supposed to pull the extruded filament upward, but it was going in reverse. It was going this way, so it was pushing the filament outward. That was quite annoying. So you don't understand this about me, but my style is that I do not like to modify componentry, internals. I don't like cutting wires. I don't like having to, do something that's possibly physically damaging or irreversible. That's just kind of my approach with things. And so because of that, I did not want to actually mess with this at first. I was kind of more inclined to actually look at the firmware. And the thing was that I thought about it, I gave it about 10 minutes, and I realized I don't feel like having to download Marlin as a source code. I believe it's Arduino. I don't want to have to download an Arduino compiler to be able to compile a version of firmware to load it on here. Like, I'm alright, like I'm good. This isn't space, and I don't have internet, and I have these resources, and this is the only thing I gotta do. No, this is the world. I have options. I could choose to not need to do the firmware. And so, yeah, I chose to not mess with the firmware. The other thing about that is when you mess with firmware like that, when they come up with firmware updates, you will have to go back in and take that source code and either modify it or cross your fingers and hope that they actually fix the bug that they had. In my case, no, there was a Marlin update, 2.06 update to the firmware, and so this extruder, like the code for it was reversed, and so it was extruding outward. And so yeah, I could have modified that. I decided not to. Instead, I went in and I reversed the polarity on the cabling here. And that was really easy to do. I just used a small screwdriver with the tabs, and you pop the tabs and they come right out. I didn't know that. Knowing that, I would have not even bothered considering the firmware. I would have just done that right away. Because to me, that is a reversible operation and it's not damaging. So, yeah. So dealing with the extruder's polarity, so it extruded the right way, and dealing with the amount of action and movement so that it would not mess with the sensors was the only problems I had with actually printing and getting it going. I printed a couple of benchies as test prints, and then I printed some airsoft loaders, right? So this is one. Right, and this is the other one I just printed. The reason why I needed to print another one is because the rail system I have for this airsoft blower is actually not compatible with this, and so I've printed another style lower that hopefully should have compatible rails. If the rails are still incompatible, then I will end up just purchasing the correct rails for this system. More thoughts. So, like I said, in 2013, I was using a Pressamental 2. It had a red heat mat, and then it also had a plastic, or not plastic, a glass kind of heating plate on top of it, and that's what I was using. So this doesn't have that plastic heating plate. It just kind of has this magnetic heating pad. I at first thought I should probably get the glass mat, but I haven't got it. And at this point, I'm accepting that no, I don't want that. I don't need it. This is not smooth. It's textured, and so to me, that's great for bed adhesion. To get the bottom layer to stick to it, because it's rough bumps. The glass is going to be a smooth surface. I'm a little bit worried about that popping right off. Other observations I've found. So I'm using PLA Plus. I did have this free PLA that was given to me, but I didn't want to run out of filament while doing these lowers, and so I didn't do that. Maybe I'll try it for the next run with them, just to see. That'd be kind of neat, huh? The stock settings for PLA and for the nozzle and for the bed are too low, in my opinion. They are set to 50 degrees for the bed, and 200 degrees for the nozzle. This nozzle, in my opinion, should be set to at least 215. 215 to maybe 225. It's going to be a little runnier, but I feel like you get good consistent results and it will lay out on the surface and give you good prints. If it's not very hot, what you run into the issue of is that this filament is hardened by the time it hits the surface, and so you have poor bed adhesion and it will pop up. And the same with the heated mat, it works in the same principle. This mat is only set to 50 by the default settings. I would suggest you at least bump it to 65. I've seen people go as high as 80 though. I found that with all my stock prints at 50 and 200, I may get lucky, but it tends to maybe get to about a half to maybe even a third, sometimes even up to halfway up, and then it'll the adhesion will go away and it will just kind of fall. And that's a bad thing. You need this to be a good firm surface because this is a flat two-dimensional path that it's using to draw, and it's drawing up layer by layer. And so when this goes away, you are removing your base for it to draw in. So it's just drawing in midair, and that's how you get these giant like coils of spaghetti and gunk that you see in failed build prints. So those are my advices about that. Like I said, I think Creality came up with a really great consumer printer that you don't have to spend any efforts trying to really figure out once you have it dialed in. I've not had to do any calibration prints. I mean, anything for calibrating since running it the first time, and that's wonderful. My experiences from 10 years ago were that I print a calibration cube, I try to print something like some plastic knuckles or something, and then everything would be out of whack. And then so I'd print another calibration cube, then I'd print more knuckles, which are out of whack. And I found that I was constantly having to mess with the Z-axis and with the four corners and having to use a sheet of paper, and there were no auto leveling sensors like we have it today, so I didn't have a means. I just kind of had to like guess it and write down the value and then set the Z offset in the firmware because I didn't have a heads-up display. And I was using like Pronterface, you know? And so that's, yeah, this is wonderful. I would imagine if you wanted to control the quality of your prints, you should upgrade this and get an enclosure or get a unit that has an enclosure so that it's a constant warm temperature in here and you can do things like an annealing process. I think that sounds pretty great. However, those sorts of things do come at a cost. You're now starting to talk about possibly $700 or $800, or I would say no, maybe you can even get away with like a $500 machine. I would imagine about $500 these days gets you an enclosure. This only costs $300 during Prime Day. I think it's maybe $400 during regular times. I highly advise everybody to get a 3D printer. The era of consumers here. It's not first movers anymore. Well, that's it. Thank you so much for joining me and for enjoying this. Please like, comment, and subscribe. I'm always open for more feedback. I will be doing more 3D printing videos, and I'll possibly do music production videos in the future. And of course, I have not forgotten Weed Science. I have some episodes queued up for you. Thanks, y'all. We love you. You have a great day.